In lab, you guys had the opportunity to investigate black ink as it came out of markers, and essentially the point of that was to understand that ink is a mixture. It's not just a pure substance. You can get it to separate, and not all mixtures are the same. Not all black ink is the same. And so you guys were able to separate the ink into its parts using chromatography. Well, what are those parts? Is that matter? What is matter? So in this unit, we're really trying to figure out what is matter, what it's made out of, how we can define it, and all the different kinds of matter that there are. So we're going to start by defining matter. Matter is anything that's made of particles. And so when we say particles, sometimes we mean atoms, sometimes we mean molecules, sometimes we mean protons, neutrons, and electrons. And because it's made of particles that have mass and volume, matter has mass and volume. That means it takes a force to accelerate it, it's attracted by gravity, and it occupies space. Okay? Solids, liquids, and gases are all matter. Air is a gas. It's matter. It takes up space. You can wave your hand through it and you can feel it. If we were to suck all the air out of the room, you would suffocate because there wouldn't be matter there for you to breathe. Subatomic particles, I mentioned, protons, neutrons, and electrons, those are also matter. Now, energy is not matter. Time is not matter. Ideas are not matter. A vacuum is empty space. That's what happens when you pull everything out. It contains no matter. You'll notice air is not a vacuum. It's not empty space. Just because you can't see it doesn't mean it's not something. Okay, it is matter. Now, what is matter and what are the different types of it? Well, this debate's been going on for a while, and it wasn't until really the 18 to 1900s that we figured out what matter's made out of, and it's all these little particles. But there was a guy named Democritus, way back, a Greek philosopher, and he was like, well, what would happen if we took something like gold or silver and we started cutting it in half? We'd cut it in half and we'd end up with a smaller chunk, and then we'd cut it in half and we'd end up with a smaller chunk, and then we'd cut it in half and we'd end up with a smaller chunk, and then we'd cut it in half and we couldn't cut it anymore. And that would be the smallest possible piece. And the Greek word for uncuttable is atomos, which gives us the modern term atom. So the smallest part of something that you can't cut down anymore, according to this Greek philosopher, was an atom. Now, atoms are the small unit of matter. They're the smallest unit of an element, and we'll talk about elements in a minute, but essentially if you take an atom and break it in half, it's something new and different. It's not what it used to be. If you take an atom of helium and split it in half, you end up with 2 atoms of hydrogen. It's something different. Atoms are incredibly small. 18 milliliters of water has over 1.8 times 10 to the 22nd, 23rd atoms in it. That's uncountably huge. It's a ton of atoms. It's because atoms are tiny. And now elements, I've been talking about these for a little bit. Elements are unique in that they contain only one kind of atom. So there are several different types of atoms, and an element is made of only one type of atom. The elements are listed on the periodic table. There's about 116 named elements. 90 of them are found in nature. The rest of them are made by man through nuclear reactions, nuclear decay, atom smashing. Okay? Compounds are not elements. Compounds are made of 2 or more different elements bonded together. So this picture actually shows a variety of things, and not all of them are elements. Some of them are, not all of them are compounds, some of them are. So if we take a look in this picture, H2O, that's hydrogen, hydrogen, oxygen. This thing is a compound because it contains at least 2 different kinds of atoms. Compound, 2 different kinds of atoms. Compound, 2 different kinds of atoms. Compound, 2 different kinds of atoms. This whole top row, these are not compounds. And the reason they're not compounds is because they're the same. We have 2 of the same atoms. So this is just chlorine, this is just nitrogen, this is just oxygen, and this is just hydrogen. Okay? So 2 of the same atoms bonded together is still just an element because it still contains only one kind of atom. But if it's got 2 or more different atoms bonded together, we call it a compound. Okay, and now those formulas I was just writing, those are called chemical formulas. They tell us what's in there. So subscripts, sub means below, script refers to writing, so this is below writing. It shows the number of atoms of each element that make up the compound. So if you take a look at H2O, H2O has 2 hydrogen and 1 oxygen atoms. This little H2 tells me 2 hydrogens. If there's no number, it's understood to be 1. So H2O, that's 2 hydrogens to 1 oxygen, and we can see 1 hydrogen, which gives us 2, and then finally 1 oxygen. O2 has 2 oxygens, NO2, 1 nitrogen, 2 oxygen atoms. So we can use the subscripts in the formulas to figure out what things are in a compound. Now, if an element changes its properties, it's because it forms a bond with something. So if we take hydrogen and we combine it with oxygen, it combines explosively. Hydrogen is very, very flammable. So you combine it with oxygen, you get a nice big fireball, and out of that pops water. Water, not very explosive. Okay, so oxygen is required for fire, hydrogen is explosive. You combine the two and we get water, which we use to put out fire. So their properties change when they form a new compound. Okay. Now, a pure substance can refer to either a compound or an element. It's made of one type of material. I've been talking about bonds. A bond is a force of attraction that holds these things together, keeps them from breaking apart. And so if it's a compound, those atoms don't come apart. It's a pure substance. If it's an element, it's only got one kind of atom. It's a pure substance. And they cannot be separated into different parts. They are one thing, and it takes a chemical reaction in order to break them apart. Mixtures are not compounds, they're not elements, they're not pure. You just physically combine things together. It'd be like if you take and mix salt into water, you have salt water. If you take and mix vegetables to make a salad, you don't have anything new, you just have a bunch of stuff jumbled together. That's a mixture. The pure substance in the mixture keeps its properties. So like I said, salt water, the salt's still salt, the water's still water, they're just together. And they can be separated without a chemical reaction. Homogeneous, if you look at the prefix homo, that means similar or the same. So a homogeneous mixture is the same throughout the entire mixture. You can't tell one part from another part from another part. So salt water is fairly homogeneous. Kool-Aid is homogeneous. Heterogeneous, on the other hand, means different. Hetero is the prefix for different. So a heterogeneous mixture is different throughout the entire mixture. So if you've ever had trail mix is a heterogeneous mixture. Potting soil, heterogeneous. You can see the different parts of it. Fruit salad, heterogeneous. Now, a lot of people like to tell me air isn't matter, but remember, matter is stuff made out of particles, and air is made out of particles. It's primarily made out of nitrogen. Okay? These are 2 nitrogen atoms bonded together. It's called a diatomic molecule. It's not a compound because it's still just pure nitrogen. There's also some oxygen floating around in here. If you didn't have that oxygen, you would breathe in and breathe out and breathe in and die. Okay? You need oxygen to live. There's a little water floating around. You can see the water condense on a cold day when you exhale. CO2 floats around. Plants take it in and use it to make glucose and release a little bit of oxygen. So that's good. Nitrogen, basically breathe in, breathe out. We don't do a lot with it. Argon's a noble gas. Nothing does anything with it. But all of these little particles are floating around in air. Air is not nothing.